This is geometry 10.2, talking about volume of prisms. The volume of a solid let me start that over. The volume of a solid is the number of cubic units contained in the interior. Basically, the volume is the amount of 3D, which is three-dimensional, space an object takes up. So what we're thinking about is how many cubes, how many dice can you fit in this shoebox? Or how many ice cubes can you fit in the particular shapes? The volume V of a prism, you got to remember what a prism is. It's different than a pyramid. The volume of a prism is the area of the base, that's the capital B, times the height. That is different than a lowercase b. A capital B is the area of the base. It's not a length, it's an area of a base. And H is your height. Now we should talk about what height is. Height is the distance between the bases. That's what H is, the distance between the bases. Sometimes the bases aren't on the bottom and top. Sometimes the bases are on the front and back. So the height is actually how deep it goes. In these examples, specifically this one, the height is up and down. But if we considered this rectangular prism to have faces on the left and right side, then the height would be the distance between them. If we considered the bases to be the rectangles on the bottom and the top, then the height is the distance between them. Sometimes we're going to need to find the area of a triangle, and we're very familiar that area of a triangle is half. This is a small b because it's a line, it's a segment, it's an edge. So it's a lowercase b, it's not the area type of b. This is half of the base times the height. And a rectangle, we could call that base times height. It's not half, it's the full, but we could call it base times height. Many people will call that length times width. It's whichever variables you like to use, whichever terminology, this and that, whatever works for you. But the volume of these prisms is always going to be the area of the base times the height. So we'll try a few of them. So here with this shape, we know this is a rectangular prism. So we need to find the area of the base, and we have to times it by the height. So volume equals capital B times H. Capital B is not an edge. It's not the base like a base of a triangle where we talk about one side. We're talking about the whole face. The whole base on the bottom. So that's going to be 12 times 5. 12 times 5 is your base. And then the distance between the bottom and the top is 8. So that's going to be 60 times 8. 60 times 8 would be 48 with an extra 0. 6 times 8 is 48. 60 times 8 is 480. Our units are centimeters. And because we have 3 dimensions, we have length and width, that made up the capital B, and then we have a height. We have 3 different measurements. This is cubic. It's about how many cubic shapes fit within inside the prism. All right, this one is a cube. A cube would have an E at the end of the name, cube. A cube implies that it is a special type of rectangular prism where the length and the width and the height are all the same. So sometimes the formula is S cubed. It's the side cubed. 5 times 5 times 5. But you can also just treat it as capital B times H, the area of the base times the height. The base is the area of the bottom, which is 5 by 5. And the distance up and down is 5. So we're getting 125 inches cubed, or cubic inches. So I think about that as being how many dice can fit inside this shape. That's what volume is. The number of dice that you could lay out to fit inside this cube. All right, so let's look at number C. They give us a hint that this is a right triangular prism. So you can't misunderstand what the shape is. But how can you find the volume? What is the volume of this right triangular prism? Many mistakes come from this, but it's relatively basic calculation, but not understanding the calculation is going to make it tougher. So we know that the volume is going to be capital B times the H, because this is a prism. It's the area of the base times the height. The question is, what is the base? Our base is the triangle. So our formula is really going to be half the base times the height. Now that's a different base. This is the edge of the triangle base times the height of the triangle. And then we are going to times it by the height of the prism. Okay, so now you have the formula. Can you still determine what the volume is? What is the area of the triangle? The area of the triangle is 3 times 1, take half of it. Half of 3 times 1. That is the area of this triangle. Now, what is the height of the prism? what is the distance between the bases? Which is 2. So you can multiply this a couple different ways. We have 2 times 3, which is 6. Take half of that. So we have a volume of 3 cubic feet. So we had to find the area of the triangle, and to do that we needed to know a perpendicular side, a perpendicular measurement of our triangle to figure out height and base of the triangle. We come over here to this one. What shape is this? It's a triangular prism. Well, how are we going to calculate the volume of this triangular prism? For us to do this calculation, we need to know the area of the triangle times the height between, or the distance between the triangles. Well, we did that over here, and the area of the triangle was pretty simple because the two sides of the triangle were 90 degrees to each other. They were perpendicular. They were bases and heights of the triangle. So we did half of the base, 3, times a height, 1. That's the area of the triangle, times the distance between the triangles. Well, when we come over here to this one, we have this triangle, and it has a height. It has a base of 6. It's kind of confusing because we keep using the same word twice. We have a base of a prism and we have a base of a triangle. The base of this triangle is a lowercase b because it's a single edge. Where over here, when we talked about base, we talked about a capital B because that's the area of the base for volume. Here we're talking about area. We want to know the area of this triangle. So this slanted side is 5. That is not the height. So we're working with this right triangle. So what we know is that it's 5 on both sides. So this is a isosceles triangle dropped on our altitude, which is going to cut the 6 exactly in half. So this is a length of 3. What is our missing height going to be? Anyone know that pattern? If you have a right triangle and one side is 3 and the hypotenuse is 5, what's the other leg? It's guaranteed. It's called the Pythagorean triple. This is one you want to be familiar with so you don't have to do all the calculations. So we're going to look at hypotenuse squared equals leg squared plus leg squared. Hypotenuse squared equals leg squared plus leg squared. We're going to subtract the 9 across to get 16. And when we take the square root, we figure out that the height of this triangle is 4. So the area of this triangle, let's think back to the volume. The volume is the area of the base. So the area of this base is half of b times h times a height, which is a distance between the bases. So we're using height in two different spots. We're using height for a triangle and we're using height for the distance between the bases. It's very confusing. I wish the terminology was the same. We're using base of the prism, which is the triangle, capital B, but we use base of the triangle, which is just the 6, which is just the side. So I can see how it can be confusing. So we know we have 6 times 4. Half of 6 times 4. That is the area of the triangle, times the distance between the triangles, which is 8. So 24, take half of it, is 12, times 8 is 96 centimeters cubic. Cubic centimeters. That is a tough one because the height was not given to us. We had to calculate the height of the triangle, the height of the base. A cube, we talked about a cube a little bit already. A cube kind of looks like a dice, a single die. It has the same length across the bottom. So I'm putting S for side. It's typically, it's a square on bottom and it's a square on every side. So S times S is the area of the bottom, times S is the area up and down, or is the length up and down. So the general rule for a cube is the volume is S cubed. Length times width times height. S times S times S. So if you know you have a cube, and you happen to know that the sides are 5, it'll come out to be 5 cubed. So the general rule is the side length cubed. All right. Last little bit. The previous solids are called right solids. This is because the bases are perpendicular to the height. Solids that aren't right, they aren't perpendicular to the base, are called oblique. They're oblique solids. We can talk about their volume. We're using Cavaliere's principle. We have 3 solids. They all have equal heights, and they all have equal cross sections. So this one here looks to be a square, and it's a square all the way up. This one is slanted. It's slanted over, but the area of the base is the same. It's slanted and has the same height. And then here we have a cylinder, circular. Area of the base is going to be the same. So all those shapes are going to have the same volume. Here you have a stack of pennies. You have 10 pennies tall, and they're stacked perfectly on top of each other. And then this stack is 10 pennies, all wiggled back and forth. They have the same volume. They have the same amount of pennies. This one doesn't have more metal pieces. It has the same metal pieces. So the calculation is the same. So here, we're going to find the volume of the oblique prism. As we lean it sideways, it gets a little bit shorter. The further you lean it the shorter it becomes. But the formula is still the same. It's the base times the height. The area of the base, in this case, is a triangle of 9 times 5. And the height is the distance between the triangles, and that has to be a 90-degree measurement. We times that by 8. So we can take half of the 9, we can take half of the 5, or we can take half of the 8. Your choice. Doesn't matter. We can multiply the 8 and the 5 together to get 40. Take half of that, which is 20. 20 times 9 is 180. 180 cubic meters. So the calculation is the same. You just need to know the perpendicular height if it's slanted over.